Today's lesson 4-4 is going to be referring to linear functions. We've been graphing quite a bit, and we're going to talk today about the functions that you learned from Miss Wheeler, except for we're going to decide whether the function is displaying continuous data or discrete data, and then of course knowing that the function has to follow the line trick where you run a line and it's got to not have x's more than once. So you remember your home on the range where the y is dependent on x, where x is domain and the y is the range. And for a function, no x is the same. Linear functions, meaning a line going in a straight line. Just a reminder, table of contents. I've noticed some of you aren't keeping up with that very well. Go to your table of contents right now and make sure that you have your page numbers listed. I'm on the back side of my first page, so you might be too. Page 44 to 45 was function, 47 was home on the range, and then skipping over to 49. So you should be gluing on the right side of your journal. I'm not going to glue this one in yet. I'm just going to fill in as we go. So linear functions, a linear function, again, you've got a line going on, right? And it is a function. And so back to it is a function in which the graph of the ordered pairs forms a straight line, hence the word linear. You can write the equations in y equals mx or y equals mx plus b form. And so we've really been practicing these two forms. The only difference with mx is you just don't have a y-intercept. And here, y equals mx plus b, you do have a y-intercept. Continuous data means that there is no space or gaps. You can use gaps here as well. No space or gaps between data values for a given domain. It is simply a straight line. We're not skipping around. There's no gaps in it. Continuous data, we're going to talk about this in a minute, but continuous data can take any value. That means it'll go forever and ever and ever, and it won't stop. You can't count it. It just keeps going. And when we say you can't count it, there's no ending point. That's continuous data. Discrete data, you can have spaces between possible data points. You just don't necessarily draw dots and you don't draw a line. You're just counting. And then that might mean that it's not going to make a straight line, and it might make dips and it might make changes. And these are things that we can count. Then that would be discrete data if you can actually count it. So a few examples here. Continuous data, the number of ounces in a glass. This can go on forever and ever and ever. I can continue to have ounces in a glass, and I can continue to go to an infinite value there. But if I say, what is the number of glasses in my cupboard? That's discrete data because I can count it, and you can go to your house and count yours, and it might be different and it might hop around on the graph. And so, yeah, that's going to be discrete. Continuous might be the weight of the chocolate chip in your hand. If I weigh it, it could be continuous. It's something that could go on forever because I have more and more chocolate chips. And if I just say, what's the number of chocolate chips in my bag, I can actually physically count them. Your bag might have a different number than mine. I don't know if, trick-or-treating, Halloween coming up, you get a bag of M&Ms, your friend gets a bag of M&Ms, and you take the M&Ms out and you count them, the number might be really different. And so the number of chocolate chips in the bag can be counted and could be discrete because we're going to have different numbers of M&Ms in each of our bags. So again, I'm going to just reiterate that discrete information we collect, we can count it, and it only has a certain number of values. For example, and so the candy bags, what about the number of people in your class? That's discrete. One class has 19, the next one has 16. It can be counted, and it's jumping around all over the place. So I've got gaps in between. Test questions answered correctly. Maybe you get 20 answered correctly on your test and somebody else gets 22 and somebody else gets 16. This can be counted. It's discrete because, again, discrete can have spaces between possible data points. I can just count that. Number of home runs that you hit. We're watching the World Series, you know, how many home runs can be hit? That's discrete. It's countable. So we think of it that way. Continuous, and I'll add some of these discrete. Number of people in a class, number of home run hits, or just number of hits. You know, that's still countable, it's discrete. Some other continuous things can be age. I know an age can be counted continuously because your age goes on forever. Infinity, although, I mean, at some point it does end, but it is still continuous. It is an infinite value. I also think of infinity in this way. I'll put the infinity sign there. It goes on forever. Age, if I do like weight of something, anytime I'm measuring the weight, it can be continuous. You know, for some of us, as we get older with age, our weight is continuous. Temperature is continuous, you know, throughout the day. It can go up or down, but it is continuous. It doesn't have gaps or spaces between it. It does continue to change forever, infinity. And what else? Length. Anytime you're measuring something in length, that can be a continuous measure. And it can fluctuate up and down, but it's still continuous. Just a reminder on your TI 84, when you're doing the assignment for class, just a reminder that we've been over this a little bit the other day, is that anytime you have an equation and you want to graph it, and you can use your table of values to help you out, that you're going to hit y equals, and that's this gray button right here, top left gray button. And you put in some kind of equation. Let's say like I have y equals 8x plus 24. Whoops, y equals 8x plus 24. And then again, your x is right there, and I hit the wrong button earlier. And then you hit equals, and then you can go second graph. I'm sorry, I didn't need to hit equals. And it gives you a table of values. And in that way, you can, you know, graph your data. Most of your graphing is going to start at 0 something. Now we know it's going to start at 0.24, and that's simply because when I entered my equation, I have plus 24. That's my y-intercept, and so I know it's going to start there. More than likely, this graph, as you go ahead and graph it, and if you wanted to graph it, instead of hitting second and then table to get the table, you could hit graph. Whoops. Should be able to just graph it. Oh, my window range is out. So if you have situations like that, you can do a zoom out mode.